Give me 20 minutes of your time and I will show you how to make your HMI applications modular, reduce repetitive tasks, and increase development speed. Sounds good? Then let's roll it. So imagine you need to add another temperature or pressure value to the screen. Up until now, the workflow looked like this. You select all the related elements, you copy and then paste them, and then you carefully relink each sub-element to new tags. Even though in this case it doesn't seem like much work, the process is tedious and prone to errors. Take a look at this tag list. Both sensor value and sensor fault tags are part of the same analog input data structure. Now, wouldn't it be great if we could just point our visual elements to that specific data structure and let Panel Builder handle the rest automatically? Let's see how to do it. First, we need to group all those sensor-related visuals together in one unit. Then right-click on the group and select Convert to Widget. This will be the place where we turn a collection of visual elements to our own custom widget. To start, give it a clear name, change the inheritance option to full. You will see how that comes into play a bit later. The description field is pretty self-explanatory. For now, let's just save the changes and close the window. At the moment, Widget is not doing anything useful. It acts as a black box and hides all the properties of inner elements, leaving to the outside world only standard groups of properties: general and position. While we're here, let's give this instance a proper name. But we have control over which inner properties are exposed to the outside world. We can organize properties into categories, just like these general and position ones. Let's say we make category custom. When we add a property, it cannot just exist in a vacuum. It must be linked to something inside. For example, if you want to change engineering units, simply find Units Label widget and tick the checkbox of the text property. Now we give the property a name and description. Aliased Properties panel shows you which properties of internal elements are linked to this outer property. You can add more if you need, and it might be useful if you're dealing with multiple elements and you want to change their colors, for example. Let's see what our widget looks like now after the changes. We have category custom, which contains property engineering units. If we change it to, let's say, bar, it will be immediately updated on the widget. Of course, we still need to work on the width of the units label. To edit internals of a widget, you need to switch to the edit mode, and it is a bit different than for a normal group. When you double-click on the widget, you will see green lock icon. Click on it, it will turn red and unlock edit mode. When you're dealing with number of grouped objects cramped together, Object View panel proves to be very helpful. Select the label and stretch it out. It is also a good idea to tidy up IDs of internal components. Instead of sensor fault indicator 1, shorten it to just fault indicator. Sensor value 1 would become just value. Oops. Somehow property engineering units disappeared from property inspector. That happened because I've changed the widget IDs and the alias is now pointing to a component that technically doesn't exist anymore. We just need to bring it back manually. What else might we need for a widget which displays numbers? How about the number of decimal places? Sometimes we don't care about precision. Like this, you put 0 and you get just number 56. It's all good, but it is just decoration. It hasn't changed how the widget functions at its core. But the second you add parameter to the properties list, it all starts to make sense. The parameter will be referencing to the sensor data structure, so name it accordingly. For the ID, let's use something like sensor ID. Copy it, you will need it shortly. Now go to the edit mode and find the visibility property for the fault indicator. In the data link field, replace this part with a sensor ID, surrounded by curly brackets and $sign. If you press enter, the sensor ID part disappears. What in fact happens is Panel Builder recognizes that we have used one of the defined parameters and just collapses the data link representation. If you click on it again, it will still be there. Now let's just repeat the same for the value data link. From the outside, we need to link our widget to a specific sensor, let's say ambient temp. Be careful and not attach parameter to a tag, but rather select data type text. Parameter is not a value, but a string with a name. Usually you do it like this. Find ambient temp structure, select one of the sub-elements, and then just manually remove the last part until you have the path and the name of the structure. Let's see if it works. And it does. Let me pull in the text simulation window. Minus 2.8 degrees here, and the same on the screen. If I trigger the fault signal, the fault indicator will appear. It seems to be a success. Now let's replace the return temperature value with the new custom widget. Copy the structure name, duplicate the widget, and paste the structure name. That's it. It's way faster, isn't it? Do the same for all sensor values. And don't forget to name widget instances properly. Okay, sensor is a relatively small widget. It's just two parameters which need to be linked. With more complex objects like pumps, benefits of this approach will become more obvious. Let me grab all pump1 related visual elements and move them to the side. Before we dive into the widget creation, we need to take a step back into Automation Builder. Instead of having each variable separately, I have created pump state structure, which bundles all related signals like mode switch, fault, running state, as well as some statistical data. That, of course, would also require refactoring of some parts of the PLC application, adding some code to collect stats, and importing newly created structures for pumps 1 to 4. Alright, let's get to work on the pump. Select all elements, group them, and convert to a widget. Give it a meaningful name and description. Add a parameter which points to a pump state structure. We want an ability to give each pump a unique name. For that, I'll add a property which acts as an alias to the text property of the name label. Verify it from the outside. Yep, the name changes. Next, go into the edit mode and relink the internal visuals to the corresponding members of our data structure. Run indicator, mode, graphical symbol, speeds, and fault indicator. And that's pretty much it for widget's internals. We can link it to pump1 structure, rename it, and move it back to its place. For pump2, All it takes is changing a single digit in the name and a single digit in the structure path. The same goes for the pump 3 and 4. Even if they don't share the same functionality, it doesn't matter. The missing data just won't be displayed. I think we can all agree that in this case time savings are way more obvious. But we aren't quite finished with these pumps yet. We still have stats like operation timers and start counters, which somehow need to be displayed to an operator. I think the best approach to this problem would be a contextual dialog window for every pump. Here's what our dialog window might look like. Buttons are linked to the respective reset command tags, while the numeric fields display operation timers and start counters. The cross icon in the top right corner simply closes the window. What will likely catch your eye are the first two run counters. Instead of overwhelming the operator with raw data in seconds, I have formatted the value into something more human-readable: days, hours, minutes, and seconds. Since there isn't a standard widget capable of this, I've built one myself. Custom widgets can host their own internal scripts to implement any internal logic you might need. Let's look closer at what's happening under the hood. There is a numeric field linked to a parameter. Anytime parameter's value changes, onDataUpdate event triggers onNumFieldUpdate function. Crucially, the function uses this prefix. This is a reference to the specific instance of the widget. In other words, each widget on your screen runs its own independent copy of the function without interfering with other ones. On line 7, I reference the numeric field widget and assign it to a new variable. Please note how it is implemented. The keyword WGT is used as a reference to the instance of the parent time indicator widget. To get the full address, the ID of the parent widget, time counter 1, is combined with the ID of the internal numeric field to create the full path. Time counter 1 dot numeric field. On the next line, I declare another variable and assign an updated value of the time counter to it. You might ask, why don't we just get it from the value property of the widget itself? To answer that, we need to understand the timing of onDataUpdate event. So the event is triggered the moment attached data changes, but before the new value is passed to the widget. In other words, the JavaScript function acts as a gatekeeper. It intercepts the event and then either update the widget by returning false or cancel the default update by returning true. And then it becomes our responsibility as developers to handle how the value is displayed. The event info object, on the other hand, contains fields like old value and new value, which we can use in our logic. That is exactly how we capture the new counter value. From there, we manually update value property of numeric field widget with the output of our format duration function. The function itself, defined below, takes time in seconds as an argument. It calculates the number of days, hours, and minutes along with the remaining seconds. It then pushes all the non-zero values into an array and returns them as a combined string. There is one catch with this approach though. The logic is only triggered when the attached value changes. To address this, I use the onActivate function. This is a reserved name for an initialization function that is invoked the moment the page containing the widget is loaded. Inside this function, we replicate the same logic used previously, with the only difference being how we retrieve the initial runtime counter value. To make it work, we must actually call onActivate function. I know it's a bit overwhelming at first, but once you try it yourself, everything becomes much clearer. There is another problem, not related to the widget though. Currently, dialog window only works for pump 1. By now, you've probably realized that I'm not exactly in the mood for copy-pasting today. So how do we keep only one dialog window and switch pump data dynamically? The answer lies in the feature called index tag set. Let me show you how it works. This feature is located under Tags item. Start by adding a new set and name it somehow. First, you need a tag which will act as your index. In my case, it is internal one, but could be external as well. Point to this tag in the index tag field. Next, create 4 index instances, one for each of our 4 pumps. Finally, we need to create an alias for every element displayed on the statistics page, for counters and for reset commands. Each cell in this table must point to a specific tag for a specific pump. For instance, the top left cell represents run counter 1 of pump 1, followed by run counter 2 of pump 1, then run counter 1 of pump 2, and so on. You can do all the mapping directly in Panel Builder, or export the list as an XML file, edit it externally, and import it back. As a result, you will have something like this: 8 aliases as columns, and index tag, which dynamically determines where those aliases retrieve their values from. Let's see how it changes things on the dialog page. For starter, I will change the title and put aside index tag value so we know which pump we currently work with. Next, take the first reset button and instead of pointing to the specific variable, click on the alias tab, expand pump's dataset, and select corresponding reset command. Repeat this process for start counter 1 and every other element on the screen. On the main page, we need a button to display the statistics for a specific pump. However, before executing load dialog action, we must first tell the system which pump to look at by writing the pump's number to the index tag. For pump 2, the only thing which changes is the tag value. What does it look like in simulation? Let's take a look. As you can see, the dialog window title updates dynamically. The run counters display values in human-readable format. When we switch to pump 2, stats values also change. Everything is working exactly as expected. Even though the current setup works, I don't like the idea of placing buttons by each pump and manually changing their index numbers. Instead, let's use what we've already learned and integrate the dialog call directly into the pump widget. I'll start by removing the existing buttons. Then go into the edit mode and add a button to the background. I'll add a small info icon to the corner to give an operator a hint that there is additional information behind it. Pop-up button will call JavaScript function Open Statistics Pop-up. I'll use the pump name property to get the value from the index tag. To use the name widget within the function, we first retrieve it as an object. Next, we need somehow to reference the index tag itself, where the index value will be written to. We could have hard-coded it, but for the sake of exercise, I'll do it differently. Add a label, which will serve as a placeholder for the index tag name. You must expose text property of this label so it can be accessed externally. Get the label widget as an object in the script. Retrieve the text property of the name widget and slice away the first character, leaving just the numeric value. Following that, use the setTag method to write that value to the tag name stored in the label's text property. And the last step, we load the dialog pump info. Just don't forget JMX extension at the end. Since we don't want to see the tag name on the page, just set visibility of the label widget to false. It will still work as intended. Now, once you exit edit mode and return to the page level, you'll see that the changes we made have automatically populated to pump 2, 3 and 4. And that's the beauty of using object-oriented approach with full inheritance. Don't forget to specify the index tag name and run the simulation. Pump 1, check. Pump 2, check. Pump 3 and 4, also there. Isn't this cool? Imagine you have dozens of significantly more complex objects across the panel. If you develop your PLC and HMI applications using an object-oriented mindset from the very beginning, you can save hours of development time and avoid countless headaches during debugging and commissioning. And the last thing for today. Inside the widget gallery, under user widgets, you can create your own personalized connections to store your custom-made widgets. By doing this, you build a project-independent library of assets and use them the same way as any standard widgets. That will be all for today. See you guys in the next one. Ciao.